expected time, right? Expected time. So here, in order to complete one activity, you are given three alternative times, three alternative time estimations. So then ultimately you should be able to take the expected time and record in this particular way, right? Record only the expected time particular event activity, right? So that is the task you have to complete here. In addition to that, you need to know the time variance, right? Then the most pessimistic time minus optimistic time. So that is the gap between them. Then divide by 6. Then take the square of it, right? That is the variance. Variance means standard deviation square. So if you want standard deviation, so you have to take the square root of variance, right? That is the that process. So in statistics, we already learned what is that variance and the standard deviation. So variance, we can obtain the deviation from the mean and take the square of it and take the sigma, then divide by the number of observation, right? Uh, in order to make the standard deviation, in order to obtain the standard deviation, so you have to take the square root variance, right? A square root of variance, right? The square root of variance. So that is a way of obtaining the expected time, then the variance and the standard deviation of time. So it is important to report here. Set distribution is a table. So by using the set table, you can compute probabilities. Now, expected if you take the project completion period in week or the month or dates, so that is the expected in overall. That means under the critical path method, so you can obtain the uh, 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 expected time, right? If it is a 50. Mu is 51 weeks. So here mu is 51 weeks, right? So now if I want to say what is the chance for completing this particular task in between 51 weeks and 55 weeks, the chance for that. So we can obtain that particular probability by using this area, right? Likewise, we can use probability distribution, right? Then normal distribution, normal probability distribution for making decision, right? Then again, we are making decision based on probability distribution, actually normal distribution, right? So here, this is so here actually we have to convert three estimated time as mentioned here. Uh, Here three times estimates into expected time. So then take the standard deviation, variance, and standard deviation. Pass approach, and then again we can go for the backward pass approach. You know that procedure to obtain the critical path. So the path, similar pattern you can use to critical activities. And here these are the steps actually you can define activities and time estimate. Take time, that is a comparatively large time, right? Duration for completing that particular activity. Individually, you have time into three categories: optimistic, most likely, and pessimistic. Then we can calculate the expected time, or TE, right? Time expected, TE, right? expected time. So expected time equals then tick time, right? Then the here 4 into TM and TP, right? So divide by 6. Then we can construct a network and we can go for the forward pass approach and backward pass approach. Ultimately, we can go for the path. Now, expected time formula for variance. This example, right? So I think previous time we discussed, then however would like to start from then first task is to then convert this. We have optimistic time, pessimistic, most likely time and the pessimistic time. So how to convert this into expected time? So you have to multiply this by 1, this one also by 1, but middle one or the most likely one you have to multiply by 6. Then you can go for the expected time E, right? So in order to obtain this one, so you have to take 2 times into 1, 1 time into 2, 4 times plus 1 time into 4, then then divide by 6 here, right? So that is the way of, then you can complete the same thing, right? You can do the same thing, multiply this by 1, this by 4, this by 1, ultimately take the total and divide by 6. So by using this particular pattern, you can go for the expected time, right? So in addition, that want to take the uh, variance. So here you can take the this is the pessimistic time, right? Pessimistic time. So you can multiply, get the 6, take the square, right? If you go back to your formula, easily you can take that, right? Here, divide by 6 and take the square, right? So in this case here, you go for the variance. Variance equal 1 by 1, we can calculate as activity, right? Then 4 minus 2 divided by 6, take square, right? So this is the way of answer. This is 2 by 6. Then take, I think your value will be 2 divided by 6, that is 0.33. Then the square of it, then ultimately answer is 0.11, right? 0.111. Likewise, you can follow the same procedure to obtain the variance. Then ultimately you can go for the standard deviation as well. Standard deviation is the square root of it. Then illustrate the project. Next question, right? Question B. So okay, expected time. So how to obtain it? Then the second one, illustrate the project by an arrow. You have to use this network. So you are having activity and the immediate predecessors, activity immediate. So you should have immediate predecessors. In this way, you can draw it, right? So in addition to that, D after A. So here, then E after C, then A, B. You can, sorry. Then E after C, sorry. E after C. Then F after BE. F after, then you can think this one. F after BE. Likewise, you can draw this network, right? So ultimately, you can link them and go for the network. Then that is the second part. Then third part, probability that the project will take less than 30 weeks, right? That is the next one, right? So how to do this task? Now, first task is to obtain the uh, yeah obtain the expected time. So I think you already obtained the expected time here. So how to obtain the expected time? Please tell me the way of obtaining it. I think last time I got it. I'm not sure actually. So you can confirm it. Otherwise, we can save. Yeah, not need to prepare now, so we can save our time. Yeah, right. There, next one. So expected time. So expected time, you have to multiply this by 4, this by 1, divide right? Take the total. Okay, totally in that is uh, next one 5.5 into 4. 5.5 into 4. That is 2 plus 5 and 9. Then divide by 6. Answer is 6. So yeah, this answer is 6. So if you want to take uh, next one, yeah, 7 into 4. 7 into 4, that is 28 plus 8 plus 6, that is 14. Then divide by 6. Then answer is 7, right? 8.5 into 4 plus 6. Then 48 divided by 6, 8. 3.5 into 4 plus 10. Then right, 6 being 3. So this one, see 8, 9, 16. Then 9 into 4, 36. 36 plus 4, 52. Yeah, 60. 60 divided by 6 mean 10. Right? Then yes, again 3. So in this way, you can calculate the uh, expected time. In addition to that, you can go to the variance, how to obtain the variance. Variance, here you can see this formula. Pessimistic time minus optimistic time by 6, 2, right? Square. Then, uh, uh, just 5 by the right 0.44. Next one, 8 minus 6, that is 2. 2 divided by square, I mean again same answer, 0.11. Next one, 10 minus 4, that is 6. 6 over 6 mean 1. 1 over, is 1, right? 1 square. So 9 minus 1 mean 8. 8 divided by 6. 8 divided by 6. Then take square of it. That is 1.77. 1.77. Next one, 5 minus 1, 4. Then 4 over 6. Take the square of it. Answer is again 0.44. Right? Then 16 minus 8, that is 8. Then 8 over 6. Take the square of it. Answer is again 1.77. Right? Then 5 minus 1, that is 4. 4 over 6. 4 over 6. Then take square of it. Again, 0.44. So in this way, we can obtain the variance, right? Variance of each activity, then expected time of each activity, not the project, right? Expected activity of, expected time of each activity, right? Now you can see the way of obtaining the answer, right? Then expected time and the variance. So after getting the expected time, we can record it in this particular way, right? Now, instead of 3 times, as mentioned in original question, so we have 3 times, so optimistic, most likely, and pessimistic time. Now, with this process, we convert it into single time point in time here. So now we can record it in this particular way, right? This is the computed expected value, expected time. Draw this curve, this network, right? It is draw the network as mentioned here. So if you go to this example, right? So how to draw it, right? Now here you can see A, B, C. I am not going to teach the way of drawing it. It has no immediate predecessor. That's just you can draw in this particular way. So you can see A, initial nodes, right? Then you to next one, A. A after completing, D after completing A. Yeah, A after completing A. Go for D, right? Time expected is we already calculated. Now 8. Then E after completing C. So E after completing C. So after completing C, so we can see E, right? Then F after completing BE, right? F after completing both B and E. B and E. So B and E. So you can see B and E here. After completing both B and E, you can go for A. Right? Go for A. Then if I go to next, G after completing C, right? G after completing C. So G after completing C, C here. After completing C, we can go for G, right? Then the last one, H after after completing F and G, F and G. So we can see F and G, G here, F here, right? After completing F and G, so we can go for H, right? In this particular way, we can go to networking, right? Network, and we can record the time in this particular way, right? However, all the activity should link with the ending nodes, right? Ending node. Otherwise, it will not be a network, right? So we have to have a link between uh, activities, right? Then arrows should be here, right? So after doing that, our duty is to report the time, right? Starting from 0 as mentioned here, then we can report the time for each activity as computed, starting from 3, 6, 7, 8, 4, 3, 10, and 3. So we can record time in this particular way, right? 3, 6, 7, 8, 3, and 10, and 3. Now we can go for the forward pass approach, starting from 0, right? 0 plus 3, that is 3. You can yeah, 3, 3. Then 3 plus 6, 8, that is 11. Then 0 plus 6, that is 6. Here 0 plus 7, 7, so you can record, you have no alternative. Then 7 plus 4, that is 11. So you have to take the highest one. As for the forward pass approach, you have to take the highest. Then delete this one, take 11. Then 11 here, 7, 11 here. 11 plus 3, that is 11 plus 3, that is 14. If you go to this path, 7 plus 10, that is 17. So you have to take the highest, right? Then highest is 17. 17 plus 3, that is 20. In this path, you have 11. Then you have to ignore that part, then take the 20. So then 20, you can go back to the 20 by using backward pass approach. How to do that? So you can start the work. 20 minus 3, that is 17. 17 minus 3, that is 14, right? Then 17 minus 10, that is 7, right? That is 7. Then 14 minus 4, that is 11, right? Then you have to take the lowest one. As per the backward pass approach, you have to take the lowest, right? Then 7 should be recorded, right? 7 should be recorded. Then we can cancel 11, right? Then 11, 7 minus 7, that is 0. That is 0. If we go to this path, for 14 minus 8, 6, that is 8. 8. So in this path, you can see 20 minus 8 mean 12. 12 minus 3 mean 12 minus 3 mean 9. So now we have three options: 9, 8, 0. So you have to take the lowest one. Then you can cancel these two to record 0. Right? So after doing that, you know the way of determine the critical path. Critical path is here. You have to consider, then the earliest time should be equal to latest time, right? Earliest time equal to latest time. Then here you can see similar characteristics. Here also same. This is also same, 17 and 17, 20 and 20. So you can link those activities. This is called the critical path is C, C, G, and F. Critical activities are C, G, and H, right? Critical path, C, G, and H. So this is the way of showing the critical path. This is the in order to mention the critical activities, you can write C, G, and H. Right here, what is the new thing behind this PERT when comparing with the critical path method, CPM. Here only one here change here. So you have to think about the different scenarios, different situations, different time estimation, especially 3 times estimation of pessimistic, optimistic, and most likely. So you have to take the expected value in order to convert these 3 time estimates into single one. So you can go for the probability and formula to obtain the expected value. So then by using the expected value, further you can go for the decision, right? So that question number 3, if you go back to the question number 3, yeah, it shows here question number 3. So you can see, yeah, question C, what is the probability that the project will take less than 30 weeks? So as per our example, yeah, then answer is here 20 weeks. Answer is, then our mean is 20, right? What we are asking here, what is the chance for now? Now if I record this one, right, this is our curve. This is our curve, normal curve, right? Normal curve here. So as per the normal curve, 0.5 on the side, another 0.5 on the right hand side. This is Z row. This is the variable, real variable. This is mu equals 20. We obtain that mu as per the critical path. Your expected time is 20. Expected project of the project is 20 weeks or 20 month or something, right? 20 weeks. So then here, then mu is 20. Completing this particular activity below 30. Now 30 will be great, that is greater than 20, right? Then 30. Yeah, this is the 30, right? So what is the chance for particular project below 30 weeks? Below 30 weeks mean completely this 50% or 0.5 plus this probability, right? Plus probability. So how to obtain it? That is equal below, right? Then you can use the formula. You know that formula for that, x1 minus mu over sigma. You already obtained as 20. Mu is 20. So how of critical activities, right? Now you know that the critical activity, yeah, here you obtain critical activities are CGNH, right? So what is the variance, right? Variance of CGNH, C critical activity, CGNH. So what are the you are not having standard deviation variance. Variance here 0.11, G 0.177, and H 0.44, right? Then if you want to take the deviation of this particular uh, activity. So you have to take the square root of 0.1 plus 1.77 1.77 plus 0.4, right? Then the deviation is, right, 11 plus 1.77 plus 0.44, right? Then that is 2.32. Then take the square root of it. The square root is 1.52. 1.52. So if you go to the answer, you can see the same value, right? Yes. Here, this is 2.32. Then your answer is 1.52. This, now you know that standard deviation and the yeah. If you want to take that Z1, or if I take this is Z1. So how to obtain this particular value, that is probability. So how, yeah, if you know this probability, you can add 0.5 for that, right? So then how to obtain it? X is 30, mu is 20, divide by standard deviation is 1.52, right? Then 10 divide by 1.52. 10 divide by 1.52. So then answer is 6.5. 6.5. Actually, you cannot, yeah, you can go for the 6.5. So here you have no 6.5. Yeah, 6.5 you have no, then you can take the maximum value here. Maximum value 0.4498, right? Then here this your value is 4.98, right? 4498. So then you have around 99.9 chance to complete this particular task below 30 weeks. Below 30 weeks, right? So normal expected time is 20. Now we are going to complete. If I change this time, this question into this one, right? So I want to change this question. What is the chance for completing this particular? That mean right? This not the 30, right? Below 24, right? Then what is the chance for completing this particular task below 24 weeks? So what would be the answer? So here, so your standard deviation, that is remain the same, right? The standard deviation and other figures remain the same, right? Right? Then again you have to draw a separate curve like this. This is x-axis, this is z-axis. Mu remain the same, right? 20. Then the standard deviation we obtain as 1.5. Now our question here, this is C. If it right, this is Z1. What is the chance completing this particular activity below 24 weeks? So that is our question as per the new question. So how to do that? So we have to go to the Z value. First of all, Z, we have to obtain the Z1 minus x1 minus mu over sigma. So here you can see x1 is 24 as per new question. Standard deviation remain the same. Mean remain the same. expected time remain the same 20. Standard deviation is 1.52. So then you have to take the value for here. Tell me the value. 24 minus 20 mean 4. 4 divided by 1.52 mean your answer is 2.63. So 2.6. 2.6, right? 6. Then you can obtain value from Z table, right? Read the Z table of 2.6. So what would be the answer? 2.6. 2.0, 2.63, yeah? 2.63. So how to obtain 2.63 from Z table? 2.6, 2.6 here, 2.63, 3 here. So then you can obtain values here. So 2.63, right? This is 0.4957, 4957. So then 4957, right? So here you can see 49.4, right? So then here point for this particular area, point 4957. This is 0.5. So actually you can obtain answer. Then your question is probability completing this activity, right? Activity below probability of this particular activity completing below, equal or below 24 weeks. This is equal probability of completing this activity x below 20 plus probability x in between 20 and 24, right? So this answer is, for the first part, your answer is 0.5, this one, 0.5, plus for the second part, in between 20 and 24, in between 20 and 24, that this answer is 0.4957. So your final answer is 0.9957. That is 99.57 chance for completing this particular activity within 20 weeks, 24 weeks, right? So if I change this question to weeks or 18 weeks, what would be the answer? So here again we can do the same thing. So I will start new slides so easily you can understand it, right? Right here again, you know that mu is 20 weeks. Our standard deviation is 1.52. Now our question is, what is the probability that the value below 18 weeks? This is our question, right? So how to draw it? So first of all, we have to draw this curve. That is our normal distribution curve. This is 0.5. Then this is Z, this is X. Then mu is sorry, this is 20 weeks, mu is 20 weeks, Z is 0. So what is the chance for completing this particular activity from 18 weeks, below 18 or below that, right? This is Z1, right? Then you have to compute what is the chance for completing this activity below 18 weeks, right? Then first of all, we have to obtain Z1. So how to obtain Z1? Z1, right? Z1 equal x1 minus mu over sigma. So Z1, x1, you know that 18 as per the new question. Mu remain the same, that is 20. Standard deviation, that is standard deviation, that is 1 point. Then Z1 is divided by 1.52. Your is here minus approximately minus 1.32, minus 1.32. So how then you have to read this one, read from Z table, right? Z table. So if you read the Z table minus, it is, yeah, don't think about minus when you are reading, whether it is positive or negative, you have to read 1.32, right? So if you go to the form table, normal table, 1.3, 1.32, 2 is here, right? 1.32, this is the answer, 1.3 here 2. Right? 0.4066. 0.4066. So how to obtain it? 0.4066. Point, yeah, 0.4066. So how you record it? Actually, this is the gap between 0 and this particular value. This is point here 4066, right? This is 0.4066. But our answer should be here, this area. The answering region is here. So how to obtain this one? Your question is here, right? This is similar to, right? This is similar to, right? This is similar to, right? This particular area, this total area mean, then uh, x below, yeah, is below 20 mean 0.5, right? Probability x less than 20. That is this, yeah, 0.5, right? Minus probability in between these two, 18 and 20. Right? So you can say probability, this part is 0.5. So your answer is here 0.5 minus 0.4066. Three, 4. That is, yeah, that is the answer. There is a chance for completing this particular project below 18 weeks, right? With the probability of a particular project below 18. or within 18 weeks. That is the answer, right? That is the answer. If you have any doubt regarding this calculation, you can ask, right? Is it okay for you? Is it okay? It or not, right? Is it okay? Yeah, I want to have your response. I'm waiting for your response. Yeah, we have one guest here. As per, I don't know. Yeah, please report your number. Otherwise, I don't know your name. I want to mark your attendance. 250. Here we have 250.009. Sorry, 009. 0 3 227 243 251 310 389 392 451 475 488 502 535 549. I think another guest here 417 417. Yeah, 417. Yeah, another one A07. So what is that? A07. Yeah, I want to I want to record. Yeah, record your attendance. Then please tell me BM guest one is here. Please rename by using your name and student number. So otherwise I don't know your name to mark your attendance, right? So last one also I have no. I think A07 here. Can you convert into real number? BM guest. So I have no idea, but point yeah 022 here we mark already. Yeah, 387 389, no, 389 we already marked. 549 we marked. 1417 we marked. That's it, right? Then unfortunately I have no opportunity to mark this one, right? BM guest, right? There are some responses. Yeah, right. A07 mean yeah 022, right? Okay, okay. How about others? 451 is okay. I said, but yeah, one number here, that is BM guest. Yeah, please rewrite and send me your number to mark it, right? Okay. However, have you got this method? Is it clear? Can you manage? So when you are making decision actually, so what is the chance? So now you know that now if it is not a easy task to estimate time, right? Time for each activity. So we have 3 times here. right? Most pessimistic, most optimistic, most likely, that is average, right? So we can estimate time for each activity under the three or more scenarios, and ultimately we can go for the network and we can determine the critical path. Based on the critical path, you can determine the expected time for that particular project, right? Not for the we can go for, then we can mark the variance and standard deviation for each activity. So in order to obtain the standard deviation, so we have to take the standard deviation of critical activities, right? Critical activities, we are not going to take the total of all activities, right? That is the way of obtaining the standard deviation. In our case, 1.52 in that particular only for critical knowledge. So how to apply it, right? What is the chance for completing this particular project below 30? So as per our example, 99% chance for that, right? What is the chance for completing this particular project below 24? Again, more than 99%. Right? What is the chance for completing this particular project below 8 weeks? So actually, we have very rare chance to complete that project below 18 weeks. So we have only 9% chance, 9.34% chance to complete that project below 18 weeks. Below 18 weeks. So in this particular way, we can make decision. We can make decision, right? So I think you have clear idea about the way of making decisions by using probability under the PERT method, right? Under the PERT method, actually, we have expected time. Then you can we have three times. Then for each activity, we converted them into single time by using the expected value under the expected time under the probability concept. Then we can make different decisions by using mu and standard deviations by using the standard normal formula and the standard normal curve. We made a number of decisions as per this question. Do you have anything to clarify? Please confirm that the process you got it or not, right? So I'm waiting for that answer, right? So you answer. Please pass your message through chat box. I'm waiting for that. If it is okay, so we can go ahead and without wasting much time. Otherwise, if it is clear, so clear not clear, we can go for other. Can you hear me, Will? You are not providing answers for my question. After marking it, you are not in the positions to answer my question now. Yeah. What is the yes? Yes, please respond. Is it clear for you to understand? Otherwise, yeah, yeah. Uh, uh, double two. I'm waiting, sir. Can you hear me well? Can you hear me well? Okay. One answer here. Yeah. Yes. Okay. If it is okay, so we can go for the next part of the discussion. So you are having similar question, right? Similar question. You can follow the same procedure to obtain them. So in this case also you are having similar type of questions, A, B, C up to K. Yeah, there are a number of activities. Draw the network and identify the critical path and what is the probability that the project will take 21 days to complete. 21 days to complete, right? I will give you 5 to 10 minutes, right? Can you hear me well? Can you hear me well? I will give you to complete this task within 5 to 10 minutes. So we can discuss your matters. If it is, yeah, okay, so we can go to another part of the study, right? Yeah. Go to this example. Is it okay? Yeah. Your response is very much essential. Can you do that within 5 to 10 minutes? Is it possible? Yes, please provide the answer for the chat box. Is it okay? If you have any doubt, you can ask, right? While you are providing answers, so you can ask questions, right? Okay, just take maximum of 10 minutes, right? I think it should be completed within 10 minutes, right? Okay. I think you are given enough time to complete it, right? Right. We can yeah, we can work on this task. Here, we have got the expected time. So how to do? So multiply this by 4 times. Here 1 time. Here 1 time. Then take the total. Then divide this by 6. That is the expected time. So how to do that? 4 into 3. 6 means 3. Right? 1, 2, 3. Then middle one is 2. 4, 5, 12. Then 5 into 4, that is 20. 20 plus 16, 36 divided by 6 means 6. Time is 6. 4, 3, 4, 5, that is 4. So after calculating, you can see 4. This is 1, 3, 5. This is 3. 1, 2, 3. This is become 2. 2, 4, 6. This is become 4. So after calculating, right? Calculate it. Then 3. This is 4 into 4, that is 16. 16 plus 14, that is 30. Divided by 6, that is 5. Here 3, 4, 5, that is 4. 5, 7, 8. 5, 7, 8. This is 7 into 4, that is 28. 28. 28. Yeah. Actually, this is 579. Please make that correction. 579. Right. Go to the question. It should be 579. Then otherwise you cannot take the integer here. Then 579 mean 7. So expected time is okay. Then take the variance. Variance mean, so you know that variance equal time pessimistic minus time optimistic. Yeah, this is divided by 6. Take the square of it. Right? So how to do that? Then 4 minus here, take a different color. 4 minus 2, that is 2. 2 divided by 6, right? 4 minus 2 divided by 6. Take the square of it, right? So your answer is 2 over 6. Take the square of it. So again, your answer is 0.11. Next one, 3 minus 1, that is 2. 2 over 6. 2 over 6, right? Then take the square of it. Again, the same answer, 0.11. 12 minus 8, that is, sorry, 4, that is 8. 8 divided by 6. Take the square of it, 1.77. Then next one, 5 minus 3, that is 2. Then 2 over 6, that is 2 over 6 square, 1.1. Am I correct? 5 minus 1, that is 4. 4 over 6. Take the square of it. That is 0.44. Next one is 3 minus 2, 1, that is 2, 2 over 6, 2 over 6, that is 0.11. 6 minus 2, that is 4, 4 over 6, the square, that is 0.44. 5 minus 1, that is 4, 4 over 6, a square, again same answer. Am I correct? 12 minus 2, that is 10. Then 10 over 6, take the square of it. It's 2.77. Right, 2.77. Next one, 5 minus 3, that is 2. 2 over 6, so yeah, square mean 1.11. Last one, 9 minus 5, that is 4. 4 over 6. 4 over 6. Take the square again, 0.44. Right. So after determining this expected time, so you have to draw your network. So what, yeah, you can see this network. Right. Now you can we can draw this network starting from here. A, it has no immediate predecessor. Right. A. Then after completing A, so you can see B, C, D, B, C, and D. Then E after completing B, E. F after completing C, F. G after completing D, H after completing EF, E and F. So we have to link E and F. E and F, H here. After completing H, you can go for I. J after G. Right. J after G. Then I and J after completing I. Right. We can record the time as expected time 8, 3, 2, C, 6, D, 4, E, 3, F, 2, G, F, G, G, 3, H, G, 4, G4, G4, 3, I5, J4, last one K. Right. So if I go to event number, you can write as 3, 4, 5, 6, 7, 8, 9, 10. Now we can report time is 0 as per the forward pass approach. 0 plus 3, that is 3. 3 plus 2, that is 5. 5 plus, that is 8. 3 plus 6, that is 9. 9 plus 2, that is 11. 3 plus 4, 7. 7 plus 4, 11. Now, here, this is 11. Here you have to take the maximum as the forward pass approach. So you have rejection here. 11 plus 4, that is 14. 11 plus 3, this is 14. 14 is 19. Now you have to reject this one, 19. You can take here. 19 plus 7, this is 26. Again, you can start the process from 26. 26 minus 7, that is 19. 19 minus 5,